Hi everybody, in this video we are going to be talking about unit 11.1.1, which is exponential notation. The premise of this topic is going to be that we're going to kind of expand what exponential notation is, and we're going to put it in expanded form, and then it's going to hopefully help point you back to why the rules are what they are. So hopefully that ends up helping you just make sense of some of these arbitrary rules, because there's not really arbitrary, because they actually are based off of some things that are happening kind of behind the scenes and happening mathematically, that then we just get to use the shortcuts and the rules for, because we show you why the rules make sense. All right, so here we go. So we've talked about this a little bit. I've given you a few examples on it, but not very many. So exponential notation, again, by definition, is just repeated multiplication. So if we have this example and I say x to the fourth, and I want you to expand it, well, again, what that means is that we're just taking x times itself 4 times. So that is the same as us going x times x times x times x. And I'm assuming that all of us would agree that writing this form is much quicker, much more efficient. Another one, if we have x squared y to the third, that's going to give us x times y times y times y. And one that is a little bit different is if we have this one, the quantity of x plus y squared. This is one that gets commonly missed. People will just say it's x squared plus y squared. That is not correct. That would be incorrect to write equals x squared plus y squared, because what that quantity squared is telling you to do is to take that entire quantity times itself 2 times. So this actually equals x plus y times another x plus y. And then in a couple more videos, you're going to see what we do with this, and we would do a process called foiling, or distributing twice. And again, that's an acronym, the FOIL, for first terms, outside terms, inside terms, last terms. But anyway, we're going to talk about that in a few videos. So if you remember that, that's great. And if you don't worry about it. We don't need to know how to do that yet. So let's have another one. Let's say we've got number 4, and we've got x squared plus y cubed. So would that look something like, how would it be similar, or how would it be different to this? Well, instead of multiplication all the way across, it's going to be x times x plus y times y times y. And then for the next two, we've talked about this difference already, but we're going to make sure we are reviewing it and we are still understanding the difference between that versus the difference of this one, where we have the quantity of negative a raised to the fourth. So one of these is going to end up being negative, and one of them is going to end up being positive. And I'm hoping that you're remembering which is which, because we have covered this topic already. So I'm hoping that you're saying the top one, number 5, is going to end up being negative, because remember, that's the same as like peel off that negative is kind of like this. And it helps you more readily see that we're just taking the a to the 4th power, not the negative as well. So this one would, number 5 would actually be written as -1 times a times a times a times a. And then the 6th one would be, you're taking that entire quantity and you are taking it to the 4th power. So we are going to say -a times -a times -a times -a. And so if we were to multiply that all out, this one would end up being positive, whereas this one, the result of it would end up being negative, because you have a single negative on this one. And here, because this negative times a negative would be a positive, this negative times the negative would be a positive, and then a positive times a positive is going to result in a positive. So that's why. So then we're going to do a little bit of practice again on evaluating the following. And again, we've done this a little bit, but we haven't worked with it too much. So we're just going to kind of remind you of this process. So if we are evaluating, and it says evaluate 5x to the third when x equals 4. So we are going to take 4 and we are going to plug it in for this x. And so it's going to be 5 times 4 to the third, follow your operations. So is that going to be 20 to the third, or is that going to be 4 to the third times 5? And it's the latter. You're going to take 4 to the third times 5. So 4 to the third ends up being 64. And then you take 5 times 64. And that ends up giving us, I think, 320. Yeah. So it ends up giving us, you can put it in your calculator, and it ends up giving us 320 for that one. For our next one, it's similar, but not the same. This time we are taking that entire quantity of 5x and we are raising it to the third power. And that is if x equals -4. So this time we've got a -4. So we are going to do 5 times, I'm going to put parentheses around my -4, and we're cubing it. So order of operation says go inside the parentheses first. Let's take 5 times -4, which is going to give us -20, and -20 cubed. So think about that. There's going to be 3 negatives, which means my answer is going to be negative. And then 20 cubed, like think about, like what would 2 cubed be? It was going to be 8. So if we're going to take 20 cubed, it's going to end up giving us 8,000. And then again, it's negative because of our negative to -1 to the third power. So we get -8,000. All right, let's try a couple more. I'm going to get rid of my pluses over here to give me some space. So then we've got x to the 4th. If x equals -2. And so we are going to plug that -2 in for that x. I'm taking -2 to the 4th power. So that's -2 times -2 times -2 times -2. My answer ends up being positive. And then, I mean, you can either do that in your head or you can put it in your calculator, but it's going to end up giving you 16 for that one. On our last problem, it says -2x to the 3rd if x equals -2. So this one's really similar. We've got the -2 already up front. So we're going to do -2 times -2 cubed. And then this -2 cubed is going to give us -8. And then our -8 times -2 is going to give us a positive 16 for that one. So essentially, we are looking at a very similar type problem to 3, because we end up taking -2 to the 4th. Well, guess what this is? If we've got 3 of them here and 1 of them here, that is the same as taking -2 to the 4th, right? Because we've got 1 here and 3 there. So that's why we got the same answer of positive 16. Okay, so let's check this table out. We're supposed to put it in expanded form and then give the value. So what we're going to get here is we're going to get 2 times 2 times 2 times 2, which we found out up above is 16. Then we're going to take 2 times 2 times 2, which is going to give us 8. Here we're going to get 2 times 2, which is going to give us 4. Here we're just going to get 2, which is going to give us 2. And then something I'd like for you to stop, because you may not remember what 2 to the 0 is. What do you see is happening between each of these? Like, what do you see that the pattern is? And I'm hoping that you're saying, well, I see that they're getting cut in half, right? Like we're being divided by 2, divide by 2, divide by 2. So what would happen if I take 2, this 2, and I divide it by 2? That should give me 1. And then let's look, 2 to the 0. That is actually going to give us 1. So you can just write 1 there. Now, you may not remember what 2 to the -1 is. Well, let's see what happens with our pattern. If we keep going like this, and we just say, oh, every answer we get, we're going to divide by 2, divide by 2, divide by 2, because that's what our base is, right? That's why we're dividing by 2, is because that's what our base over here is. So what would happen if I took 1 and I divide it by 2? That's 1/2, right? So it's 1/2. What if I have half of a pie? Ooh, that's a bad circle. What if I have half of a pie and then I divide it in half? That gives us a quarter, because that's what we're doing here, right? I take a half, and if I divide it in half, I get a quarter. Well, now if I have a quarter of a pie and I divide it in half, what am I left with? I'm left with an eighth, right? We're going to left with an eighth. You can also do this with your fractions, right? We can do 1/4, and if we divide it by 2, we keep, we change, we flip, and that gives us 1/8. So that's how you can do that too. All right, so let's go back up and say, okay, well, how in the world do I go from this to 1/2? Well, they're just, they give us a different way to write exponents when we've got a base and an exponent in the denominator. Because honestly, if you're typing that out in a paper, that's a lot of space. Like if you're having to go like this, that's a ton more like space on your page versus writing it like this, 2 to the -4th. So the negative up here is just a way for them to kind of more in a smaller amount of space on your paper. It's a way for you to say 2 to the -4th is actually 1/2 to the 4th. And so again, it's just a way to write it, so it takes up less space on your page. So that means that 2 to the -1st is going to be 1/2 to the 1st, which is just 1/2. And then our next one, which would be 1/2 squared, is going to be 1/4, which is what we're getting in that right-hand column. And then here, that 2 to the -3rd is going to be 1/2 cubed, which is just going to equal 1/8 for that. All right, so now I would like for you to pause the video, and I would like you to try to do the right-hand side of this table. And then I'm going to go ahead and do it for you as well, but I would like for you to pause the video and see if you can fill in the table, those right 2 columns on your own. All right, here we go. Expanded form, it's going to be 10 times 10 times 10 times 10, which is going to give us 10,000. Then we're going to get 10 times 10 times 10, which is going to give us 1,000. Then we're going to get 10 times 10, which is going to give us 100. Then we're going to get 10, which is going to give us 10. And what are we dividing by this time? Are we dividing by 2 again? No, we're dividing by 10 because that's our base, right? So we're going to divide by 10 this time. So we're going to divide by 10, divide by 10, divide by 10, and that's what we're going to keep going all the way down. So we're dividing by 10, divide by 10, divide by 10. And so that should help you fill in that right-hand column. So if I take 10 here and I divide it by 10, that's going to give me 1, which is what 10 to the 0 is. And then if I take 1 and I divide it by 10, that's going to give me 1/10 or 0.1, right? If I take 1/10 and I divide it by 10, or I take this decimal form and I move it 1 place to the left again, that's 1/100th. Or you could write it as 0.01. And if I divide 1/100th by another 10, I'm going to get 1,000th, which is going to be 0.001. So now let's go back over and fill in the rest of our chart. So 10 to the -1st is going to be 10, oh, sorry, not 10. It's going to be 1/10 to the 1st, which is just 1/10. And then this 10 to the -2nd is going to be 1/10 squared, which gives you 1/100th, or as a decimal, 0.01, which is 1/100th. And then this 10 to the -3rd is going to be 1/10 cubed, which gives you the 1/1000th, either as a fraction form or in decimal form. So something I want you to think about now, because we're getting ready to write in one of these rules that I'm going to talk about. What happens with 0? Like what would happen? Let's pretend, and I'm going to take up a little bit of space for a second on this right-hand side. I wonder if I can go like this and move this over and just write small. Okay, so let's say if on this one, if I said, let's take 0, we're going to go 0, 0 to the third, 0 squared, 0 to the first, 0 to the negative first. So let's go at least that far. So here, if we were expanding it, we would go 0 times 0 times 0, which gives us what? 0. 0 times 0, which is going to give us 0. 0 to the first is going to be a 0. And that's going to be 0. Oh, I forgot to put one in here. Let's do 0 to the 0 power. And then we're going to do 0 to the negative 1. And let's go to the right-hand side for a second. And every time on the previous two examples, we said we're dividing by something, right? Divide by something, divide by something. Is it possible for us to divide by 0, to divide by that base of 0? So the question is it okay to divide by 0? No, that's undefined. So first of all, we can't really use that process to divide by 0. And then if you guys look on our previous two examples, the number to the 0 power equaled 1, right? Well, okay, 0 to the 0 power. Does it make any sense for it to equal 1 here? No. So this 0 to the 0 power ends up being undefined. And then this 0 to the negative 1, that would actually mean this. That would be 1 over 0 to the first, which is 1 over 0. Does that make sense? Can we have 0 in the denominator? No. So even if you kept going, so if we had like this, 1 over 0 times 0, that equals 1 over 0, which is again undefined. So this is also undefined, undefined. So the only time, the only exponent that you can take 0 to is going to be some number that is greater than 0. So it cannot equal 0 and it cannot be any negative. It cannot be anything less than 0 for that. All right. So now that we have kind of talked through that, come back over here and let's write in our rules that we can conclude based off of what we were just talking about and what we were discovering in the table up above. So any number or variable, raised to a power of 1. Well, what is that? What is the answer to that? Any number or variable raised to the power of 1, what happens? Here's power of 1, here's the power of 1. It's that number itself, right? It's going to be that number or variable itself. So if we have something like, here's your generic rule, n to the first, that's going to equal n. It's going to be that same number or variable. Any non-zero number, or variable raised to a power of 0. So think about that. Any non-zero, so any of these, any non-zero number raised to the power of 0 is going to equal what? 1. It's going to be equal to 1. So that one would mean if we take n and we raise it to the 0 power, that's going to equal 1. As long as n does not equal 0. So the base cannot equal 0. All right, the quantity of 0 to the 0 power is what? What did we say it is? It's undefined. It's undefined. There is no definition for 0 to the 0 power. And then for any non-zero number n and any integer, think about what an integer is, any positive or negative whole numbers, we're going to have n to the negative x. What will that equal? What's another way we can write that? We can write that as 1 over what? N to the x, n to the positive x. So for example, again, and we did those up here, right? So here was the rule for those situations. So if we have something like this, 5 to the negative second power, that's going to equal 1 over 25. So you can write it like that. All right, so let's use our rules and these couple of examples. And it says 3x to the 0 minus y to the first when x equals 12. So I'm going to plug those in first. So we've got 12 to the 0 minus a negative 6 to the first. And then, well, what does this equal again? 12 to the 0. Back and look at your rules if you don't remember. That should equal 1 minus, what is 6 to the first? Or sorry, not 6, but negative 6. That should give us back itself, negative 6. So then 3 times 1 is 3, minus a negative gives us a positive. 3 plus 6 is 9. And then let's try this one over here. We've got 6 that we're plugging in. We're raising it to the negative second power, and then we've got 6 to the 0. So 6 to the negative second, how do we make that a positive exponent? We're going to write 1 over 6 squared times what 6 to the 0? Should be 1. All right, so now let's evaluate this. 6 squared should be 36. 1 over 36. Again, because this is the same as 6 times 6. It's times itself that many times. So that gives us 1 over 36. Okay, that's it for this video. Thanks for tuning in.